Hello friends, myself Rajendra Mahajan presenting my video on Fourier transform. Example, evaluate integral from 0 to infinity, integration from 0 to infinity of sine square x divided by x square with respect to x by using Parseval's identity. And to evaluate it by Parseval's identity, if we have f of x is equals to, if we have f of x is equals to 1 for mod x less than or equals to 1, f of x is equals to 1 for the condition mod x less than or is equals to 1, and the second value is 0 for mod x greater than 1. And for this function, then Fourier cosine transform is given by Fourier cosine transform for this given function is obtained as fc lambda is equals to sine lambda upon lambda. Do it yourself how to get this Fourier cosine transform by watching my videos on the cosine transform, and then using Parseval's identity for that Fourier cosine transform. We have integration from 0 to infinity 2 by pi integral from 0 to infinity of f of x fc lambda and its square with respect to lambda as integral from 0 to infinity of mod of f of x and its square and its integration with respect to x. Then 2 by pi integral from 0 to infinity. The value of fc lambda is sine lambda by lambda. Therefore, it becomes sine lambda upon lambda and its square with respect to lambda as splitting that integral as 0 to 1 and 1 to infinity. In between 0 to 1, the value is 1. Therefore, it becomes 1 square and its integration with respect to x. And second value is 0 between 1 to infinity. And then transferring that 2 by pi to other side, we get integral from 0 to infinity of sine square lambda upon lambda square d lambda as pi by 2, and integration of dx is x, and limits from 0 to infinity. Substituting the upper and lower limit, we get pi by 2 multiplied by 1 minus 0, nothing but pi by 2. And then as it is definite integral, replacing lambda by x, we get the required result, integration from 0 to infinity of sine square x upon x square with respect to x as pi by 2. That is the required value. Please like my video, share it, as well as subscribe to my channel. And to receive the notification, please press the bell icon. Thank you. Thanks for watching.